you can actually recognize activities from that. So the one approach that's pretty easy is so-called event triples. And what you have is an event vocabulary. This is, well, this is entering E, S for stopping, M for moving, and H for holding. And if you go back to this example, you have E moving, E, H, E, M, H, M, S. S is this example. And then you take this in pairs, in threes, always three events one together, which is to give you a little bit of context. You have a current action, you have the action that went on before, and you have the event that happened afterwards. And then you just count and compare this to your examples. And you have the event categorization for your examples. And so where you typically have a certain sequence of events going on. So first I'm going to move a little bit, and then maybe I'm going to move my arms or something, and then I'm going to move a little bit back or so. This could be shaking hands. And of course, and the advantage of this is that you get a little bit you get more abstract. You are not so much on the appearance anymore. So this is really the only level that you can talk about activities going on because of that appearance versus function problem. There are lots of other methods, but this is one of the most simple. Okay, so let's summarize this. Tracking associates objects over time in various ways. It can fail relatively often. There are lots of edge cases. And even as we can see, there is not much hope there because even in humans, tracking fails quite often. If you see a person moving into a crowd and then he's moving out somewhere, we will have a hard time finding him. And there's a couple of robust approaches that have very little information, but work. And in general, with tracking, you still have no clear decision between relevant and irrelevant because your input is so ambiguous. All this results in a very hard problem for recognition. It has to be said that the state-of-the-art progresses very fast, and the robustness is something that is being worked on very much, and we will see all these algorithms work in more and more cases. But what we still don't see is this action interpretation problem that I touched upon in the previous slide, because all these sequences, these events, what constitutes an activity, what sequence of events constitutes an activity, that is still something that is given by humans. And well, if after 20 or 30 years of research into symbolic reasoning, we still have this part given by humans, you can really assume it's a hard problem. And there will not be an automated solution for the sequence learning. There are lots of ideas for this, but they also always involve lots of human input. So this is something that won't work. And give you a little bit of summary about the different stages. All these things I talked about are usually done in a processing chain. So first you have this surveillance camera here, and it's looking at the wall. Well, and then the images are going to be digitized, and you have a cup. This is intended to be a sequence of frames. And first you have to locate your humans, segment them out so you get a body shape, then you track this body shape, and you get a path looking from above. You summarize this somehow, and then a classification comes out, and well, this is walking. And I only talked about the parts in the red box here. The classification part, as talked about, it's not about surveillance, but general machine learning is later in the evening, and a talk about camera technologies right after this one. So if you're interested in that, stick around. Right, couple of systems and implementations. One problem with implementations is that, of course, the implementations that are actually out in the open and getting used are not available to us. No surveillance company wants to look us at their code because it's, well, yeah. And so the only option we have is use research implementations or build our own. And well, I'm a researcher, so I use research implementations. And I have to tell you, the quality and the robustness, and especially the speed, they are not very good. And also because research applications, they have a very specific problem, and design an algorithm, and the software is really just there to show you that the algorithm works, and on this particular situation. And so many of the research applications are very specific with regards to their input, which also makes them difficult to integrate. But one nice library is the open source computer vision library, which is produced by Intel and has lots of contributions from researchers. And it has a very comprehensive algorithm support. So if you read about any algorithm and you don't have an implementation yet, but you want to check out if it works, go check out OpenCV. Chances are it has it. And it's also pretty fast. You can read lots of video and all that formats. And it's written in C, has bindings for Python, so scripting language, people can check this out too. And it's available in Windows and Linux. The main drawback is it doesn't do anything by itself, it's just a library. But for your reference, there's a link here in the slides. And then there's the software application that we developed at our group, which is focused on integration. And it has only very basic algorithms and a plugin architecture. It's called Icewing. And has support for grabbing from Firewire, Video for Linux, and so on. And it has a very good support for plugin programming and communication between plugins. And these plugins can be written in C, C++, Python, MATLAB, a couple of others are forthcoming. And it doesn't run on Windows, it only runs on Linux, Unix, and Mac OS. But what you can see here is it's an example of this application. So this is the skin color detection, and this is the trajectory here on the right. And one of the things that makes Icewing interesting is that it allows you to set all the parameters for the algorithm interactively. So this is one of the parameter boxes down here for the two windows. And if I change something here, it immediately gets applied to the output window. So you can get a feel of how algorithms perform. And there's also, it's at SourceForge, you can download it. All right. So, to conclude, surveillance visual motion analysis has been developed for indoor presence detection only. And this is the only thing that really works. Everything else is edge cases. And the current methods are especially not robust for public areas. And when you want to get human-like results, you have to provide a lot of specific human input. And this is maybe something for the Big Brother crowd, who think that this might, give lots of information about what we are doing. Well, we only get lots of information about what a person is doing when you expend lots of effort at the moment. So this is not quite there yet. And especially the last problem, the Roadrunner problem, as I call it, the one that you really have to take a predictive stance, that you cannot only interpret, you have to make a prediction of what's going to happen, to act upon it. That's going to stick around for a while. So in summary, I wouldn't stake my life on it, and I wouldn't even pay for it. Right. Just a little bit of ideas where it's going. We are going to see more integration. All these approaches that I outlined, and there are lots of more, they're going to be integrated to make the systems more robust. And then there's this notion of the 30-pixel man, which is the low-resolution example from the beginning. There's lots of work on that, interpreting these kinds of resolution images. And one thing that, of course, we are also very interested in is interaction analysis. If you have two humans or a human and a robot telling what they do, it's actually can be easier to tell what a person is doing when you see who he's doing it to or who he's working with. And this is a research direction. And also one offer I wanted to make is for anyone who is interested in the details or wants to work on these technologies. And we could do a little bit of a workshop at the Congress here, if you want to. And if you're interested in that, just talk to me afterwards. So, with that, thank you for your attention. So, any questions? Yes. Could you take a mic, please?
Two questions. First of all, the skin color detection seems to have some racial implications that I was thinking about just now, especially if you start learning in an environment where you have groups of different race in different social classes. For instance, in an area where most of the crime or a lot of the crime is perpetrated by people of a different race than I was wondering how that works with the computer learning, and sort of thinking about the racial implications a little bit.
Yeah, maybe just to that. That's a very correct question and very good question. And of course, my personal assumption is always that skin color detection was developed by white computer science people, like this, and because it's very easy. But actually, what you can do is you do online adaptation. So once you have a body model fitted to a person, you basically know where hands and face are, and you can use that to determine the color model of the person you're looking at from the image. That's a little bit more difficult, and it has the initialization problem, but it is possible. And this is one way that you can easily do black, Asian, whatever color you want. But it requires online adaptation.
And the other thing I was thinking about is if you're going to do learning, if you want to have lots of behavior viewed from different angles with the description on it, you could look at a large collection of movies for which you have the script. Because even if you don't know who is David and who is Jack, you still have the words for the behavior with the actual image. But that's just because there's such a large collection of it.
Yeah, that's a very interesting idea, actually. Maybe someone from the surveillance community should check that out. But actually, for human-human interaction studies that we are doing, this is what we are doing. So the example from before is from this experiment where we have a set script. We always know what the person is going to do, and the only thing that's changing is how fast they do it and in which ways. So that's the same idea.
Okay. I have a question about a question/comment about Effect TV. Do you know about that project?
No, actually I don't.
Okay, I'm not sure if they do any motion detection or if it is just a bitmap trick, but it has similarities. Some Japanese researchers using it for VJ performances and so on, but it's also on SourceForge.
What's it called again?
Effect TV, EFFECTV.
Okay, thanks.
SF.net.
Check that out.
Check it out.
One problem which comes to mind, and possibly is easier to solve than the behavior of humans, is the behavior of motor vehicles. You could use this technology for, say, detecting congestion or collisions on roads and motorways. Do you know of any applications of machine vision in these fields? Well,
there's lots of it. And the whole tracking field was basically, tracking is from military tracking of targets. And that's where it originated. And then there's a whole huge field that is using this for traffic analysis. And actually the sequence example, sequence learning, sequence interpretation example is from a traffic analysis application. But you have a much simpler problem in traffic analysis, because there's much less overlap and cars don't change shape. And not unless there's an accident, of course. So, actually, one of the problems of the field is that it has tried to take methods developed for this kind of problem and use it for tracking humans, and that didn't work so well. So what you are seeing currently is new methods being developed for these two different application areas. So there's still research going on in machine vision for traffic analysis for rigid objects, as you would say. And there's a different field that's trying to do this on humans. Does it answer your question?
Yes, thank you.
All right. Any more questions? Okay, so if anyone is interested, just talk to me. And so I can use the time for a little announcement. The one is the hacking CCTV talk that's going to be right afterwards is definitely very interesting to anyone working in this field and or interested in camera technology. And there's also going to be a talk about video surveillance at German universities later in the day. Thank you again.